Hi. Let's go through the answers here for question 3. Um, the last day, just recapping from the last day, we had question 3, part A. We have to, given that Jm is the vector common U and Jn is common V, write in terms of U and V an expression for Jk. So, this is part A. To get from J to K, we have to go through 3u's. So JK is 3u. Now for M to N, to go from M to N, to get from M to N, we will travel through the arrows that already have common letter names. Remember that. Travel through arrows with common letter names. Sounds like an adventure. Travel through the arrows with common letter names, and you shall succeed in your quest. Okay, so we're going to get from M to N. We're going to go from M to J. So we'll take a MJ arrow, and then we'll go from J to N. J to N. So let's replace MJ with a letter. MJ is a negative U, and JN is a V. So you can write it like that, or if we take the plus V and put it in front, you could have a V first and the minus U next. Both answers are correct. So let's tick it off. 1, 2. Both answers are possible. You just have to show one answer. Now, part C. We have to show KL. This is where we reached the last day. We stopped here. To get from K to L, we want to start at K and end at L, and we need to travel through roads that already have names. Let's think about it. We know that this road here is a U, and this road here is a U. We also know that we have a V here, and we have a V here as well. So if you want to get from K to L, travel through arrows with common letter names. We travel this way to get from K to L. To get from K to L. So we will journey from K to J, and then we'll go from J to L as the plan. Let's replace it with arrows. Minus 3u, because there's 3 u's in reverse, and then add 3 v's. We can write it like that, or if you want, we can put the 3v first.
Hey Dad, I think I caught Vader and Red.
Right, 3v minus 3u. Two possible answers. Let's see. You could write it like this, or you could write it like that. Okay. Well, I find this one looks a little friendlier than that. That looks a bit abzucky. So I'm going to go with this. All right then. Now let's look at part 3 of the question. They said use your findings in B part 2 and deduce 2 geometrical relationships. This is part 3. Deduce 2 geometrical relationships between KL and MN. Okay, they didn't draw arrows on them, they just have them like lines, the line KL and the line MN. Okay, now when they say geometrical, they just mean shape and size. Geometry is about shapes, is the study of shapes and their sizes, so and their positions of orientation. So you want to know if these lines are of the same length. I teaching right now. If these lines have the same shape, length, direction, those kind of things, how they look. So 2 things about them. Now let's just look at the answers from here. We want to compare MN, which is this answer here, and you want to compare KL. So let's see here now. MN is equal to V minus U. That's the vector MN. And the vector KL is equal to 3V minus 3U. Do they look similar? Do they resemble? They both have V's and they both have U's. But this one have 3. Well, let's just play around with it and factorize this 3. If they have 3 common to both terms, you put it outside and the V minus U will go in brackets. That V minus U is the same thing here. That means KL is equal to 3 MNs. 3 MNs. Enter MN is a V minus U. MN is a V minus U. So this V minus U is an MN arrow. So what you've shown there is that KL is equal to 3 of these MN arrows. Okay, so what can we say in terms of geometry? Well, you remember your notes. If one vector is a multiple of the other, meaning like it's 3 times a vector, multiple means multiply. If one vector is a multiple of the other, they are parallel. So you could say here, point number 1, KL is a multiple of vector MN. Therefore, they are parallel. Okay? That's from your notes. The other thing you can say is that because it's a multiple of 3, you can say the size now. You can say that this is one geometrical relationship. The other geometrical relationship is that the line KL is 3 times KL is 3 times the magnitude or size of MN. You could use the word size, you could use the word length, you could use magnitude. So that's your two answers there. You need two relationships, and that's your two relationships there. Okay.